All right, thanks everyone for joining. So today we are meeting to discuss about mastering PostgreSQL upgrades. So myself, Abby here, and here we also have Money.
Hey, hi everyone.
Thank you.
Nice to have you guys.
Yeah, thank you for taking time to join this webinar, and I think it's going to be pretty interesting for everybody who are planning to upgrade their PostgreSQL instances, and also people who are going to going to be looking into this webinar and understanding that there are advanced features with the newer versions of Postgres, and it's going to be very helpful for you all. So today, as I already mentioned, we are discussing about PostgreSQL upgrades and how do you master them. And we are from Hexa Cluster. All right, so what do we have in the agenda today? So we'll be talking about Postgres versions, and then the release cycle. And then we'll also be understanding how we could choose the right major version for us. That's an interesting item, right? Like, why not we just choose the latest major version? Yes, that's what we should do all the time. However, let's also understand how you could choose the right major version. And then how do we prepare for an upgrade? And at the same time, the upgrade techniques involved, the points you should remember, Q&A session. We'll also try doing the best to perform a demo as well with all the Postgres upgrade techniques. Let's see how well we can go with that, right? So let's understand the Postgres versions to begin with. So the important point that you need to know, almost this is applicable for any software technology, you have major and minor releases. So until Postgres 9.6, a major version is indicated until its first decimal. So 9.1, 9.2, 9.3, 9.6, all of these considered as major versions. And a minor version is actually determined by the second decimal, right? So 9.6.1, 9.6.2, etc. are minor versions. That changed starting from Postgres 10, right? A major version does not include the value after the decimal anymore. So 10, 11, 12 until 16, right? Or going forward, the future releases, 17, etc., are going to be the major versions. So minor version is basically determined by the first decimal. So 10.1, 10.2, 10.3 are going to be the minor versions of Postgres 10, right? So this is just something interesting that you all need to be aware of. Let's also look at the Postgres versioning policy. So a major version is usually released once a year, and that has been the trend since much more than a decade, right? And a major version is usually released in the fourth quarter, last quarter, either September or October, right? And it's supported for 5 years from its initial release. So what it means is, after 5 years, there will be a final minor release, and there will not be any more releases for that major version. What it means is, if you have any bugs or any security vulnerabilities detected, that will not be supported by the Postgres community. And a minor version is released once every quarter, right? So it's usually second Tuesday of the second month of a quarter, right? That's when you see minor versions released, which includes critical bugs or some fixes or some security vulnerabilities, fixes to security vulnerabilities, etc. So considering this, period of 5 years, right? The currently stable versions are Postgres 16, which was released, in the last quarter, of the last year, 2023. So Postgres 12 until 16 can be considered as a stable versions or supported Postgres versions. So what it means is Postgres 12 is going to be end of life after November 2024, because it was announced in November 2019, right? Currently unsupported versions are Postgres 11 and earlier. So If you're using Postgres 11 or 12 or anything earlier, you must definitely look at the upgrading or strategy. Now choosing the right version, right? So to choose the right version, all we need to understand is the features to begin with, right? So let's now talk about Postgres 12. So we will go from Postgres 12 until 16 and see some of the major features you should be aware of in all of these major releases. However, please do note that these are not just everything, right? So there are several more features that got published, but we are just highlighting a few of them, right? Just highlighting a few. So at the same time, whenever you have any questions, please feel free to post them in the chat, and we will try to answer them. At the end, maybe we'll have a 5 to 10 minute Q&A session at the end, and we will be able to answer. So let's talk about Postgres 12. So Postgres 12 can technically be considered as a very developer-friendly release. So if you would have looked at Stack Overflow surveys, and if you have looked at DB Engine rankings, you see Postgres popularity growing a lot, right? And that is because Postgres is not only supporting the admins and the users, but it's also supporting developers in variety of ways. So one of the thing is especially the generated columns to begin with in Postgres 12, right? So earlier, the insert or update statement had to compute and insert into a column, but you now have the generated column. Similarly, there are several improvements to partitioning. Postgres 11 was definitely a breakthrough for partitioning, right? With a lot of features added, but Postgres 12 has added the much needed features in partitioning, like foreign keys to reference partition tables, non-blocking attach partition, many more partitioning improvements, right? You can actually have thousands of partitions starting from Postgres 12. And it's going to be really doing the partition pruning and elimination effectively. There are several optimizer improvements and indexing improvements. And while just-in-time compilation was added in Postgres 11, it was made default in Postgres 12, right? And much needed admin views, like looking at the Postgres as looking at the progress of index creation and cluster commands, right? It was much important for administrators because it was very difficult to understand what state it is while I'm creating an index, right? How can I see the progress? When do I expect it to be completed? Now you have all that progress displayed. You also have the opportunity to compute extended statistics for multi-columns and the much needed SQL JSON path implementation. So these are some of the Postgres 12 features which really made Postgres 12 extremely popular for developers as well as admins. And now let's also look at Postgres 13. So Postgres 13 has really implemented a lot of performance improvements. One of the things that I really want to highlight is the parallel vacuuming as an example, right? So you would now be able to, starting from Postgres 13, you will be able to run parallel vacuum. What it means is when you run vacuum on a table, any of the underlying indexes, right, for that table can actually be vacuumed in parallel, right? So you will have multiple indexes being vacuumed in parallel. At the same time, there are many people who actually got surprised when they migrated from Postgres 12 or earlier to Postgres 13. The biggest surprise was the reduction in the database size. What do we mean by reduction in the database size, right? It's basically the deduplication. So when you have low cardinality columns with lots of duplicates, right, and you have an index on it, you will be able to see the index size actually reduced. More than 90% of the indexes in any Postgres database that we have also seen are all B-tree indexes. So you would be able to see the index size reduced because it is now deduplicating it. So you would not have multiple entries for duplicates, right? So it's a single index pointer to multiple tuple identifiers. And there are some configuration parameter changes. At the same time, logical replication improvements as well, especially with partition tables. And again, each release has added several system views for visibility, right? And there are also JSON path enhancements, like SQL JSON path was announced in Postgres 12, and there are improvements as well. So Postgres 13 technically has made it great for performance, especially because it can really reduce the database size, and at the same time also help some of the maintenance operations work better, right? With some performance improvements, especially for developers. Postgres 14 is again one of the interesting releases, which was developer, administrator friendly, as well as with really good performance improvements. So Postgres 14 actually became a talk of the town at that time with the support for out parameters with stored procedures, right? At the same time, even with B-tree index improvements, right, it was able to reduce a lot of index bloat. And there are also, I mean, the index bloat was something which was always troublesome for performance, right? So that was also handled. And the biggest improvement, which actually made a lot of people upgrade to Postgres 14, a couple of years ago, was the vacuum becoming less aggressive, especially with transaction ID wraparound conditions. What we mean by that is, in Postgres, you have a setting, right, which is going to identify what are those tables that have the transaction ID age going beyond, freeze max age. So there is a setting called vacuum freeze max age, right? So now, regarding the vacuum improvement, what it actually does is, what Postgres 14 gives us is, whenever there are such tables with age going more than the default 200 million age or whatever age we set, right? In that case, instead of scanning every page, it only scans the relevant pages. So earlier, transaction ID, the wraparound vacuum was considered very heavy and IO intensive. So that is reduced with Postgres 14. So another interesting improvement is the libpq pipeline mode. Especially when you have a lot of batch operations, you would be able to reduce the round trips between your client and server. So this way, you would be able to, especially for applications and databases that have got this network bottleneck, will be able to take a heavy advantage, right? So libpq pipeline mode is one of the advanced features. And another great improvement with logical replication, which many people have taken the best benefit of, is the streaming of in-progress transactions, right? And there are several other improvements, especially related to parallel queries and partition tables and vacuuming. From security perspective, right? While there are always minor releases of major versions which are always handling the security vulnerabilities, right? From security perspective, Postgres 14 has implemented the scram SHA-256 encryption technique as the default encryption technique, right? That is to especially support those installations which are, going default, because, Postgres is such a database which can be really installed on tiny embedded systems too, right? So in those systems, you may not really tweak some of the settings. So in this case, it's important to have some of the default settings which do not, disrupt the asset properties or certain security standards, right? So that is why some of the things are made default. So similarly, there are lots of system views as well that got implemented. And from security perspective, again, new roles were also added. So instead of having a role which is individually or individually maintained with select or read access or write access on certain chunk of tables or all tables of a schema, instead of maintaining a group and manually, or having some amount of work done in order to grant read access on all objects, right? Instead of doing that, you have PG read all data and PG write all data roles. These roles help a user get read access to all the data. Write all data will give write access to all the data, right? So these are some of the special roles that are also implemented to simplify the user experience. Postgres 15 is again another developer and administrator friendly release, right? So it implemented the support for merge. So that was one of the interesting things because users or developers had to always handle that using insert and on update conflict, right? And you also have to specify the constraints or columns which have to be considered to identify whether a conflict really happened, right? Now all of that can be really handled by the merge command. So this simplified a lot of Oracle to Postgres migrations and other database to Postgres migrations too. So you do need not do a lot of changes, right? And another interesting thing was the logical replication, right? You have the ability to specify column lists and row filter conditions at the publication level. So that was one of the other interesting improvements. And the JSON format logging, as well as from security perspective, right? So
Yeah, this is another thing that got implemented where we restrict the users from creating objects at the public schema array. So until previous versions of the Postgres, any user who has connect privileges to a specific database would have the privilege to create their own objects. This was considered as a security violation and an overhead for the DBS as well, because anyone can create a large object and make the file system occupy it to 100% level. So this feature actually restricts the user to not create any objects at the public schema.
great, great. And also the compression algorithm implementation at the same time, server-side compression technique while using PG-based backup. Some of these are much needed enhancements, especially to reduce the amount of data that's in motion between one server to probably over the network to some other could be backup server or another storage which is connected over network. So again, to like for checkpoint process as well as some other there are several other roles that also got implemented as usual, like starting from Postgres 12 or even with previous releases. If you notice the release notes, you would always see some of the new roles always implemented, some of the new system catalog views or maintenance views for users always introduced with new releases, right? So these are all based on user feedback, user request. There are lots of contributions that always make it to the release. So there are also partitioning improvements. Partitioning improvements have been happening at extensive level, each release to release, right? Making Postgres default partitioning technique with even foreign data wrappers go to the next level of sharding. So Postgres can now be proudly considered as supporting the sharding technique with such amazing improvements with partitioning, as well as the improvements that also happened with the foreign data wrapper of Postgres, which is Postgres FDW, right? And Postgres 16, which was released, I would say a few months ago, right, last year, 2023, had got much bigger improvements to, especially related to parallelization and some of the, I would say these are all the planner level or the optimizer level improvements, right? And the major improvement which everybody was excited about was with logical replication. One of the interesting challenges most of the users had when they have implemented Postgres in production is when they have enabled logical replication. Because when you are enabling logical replication to stream or to replicate selected tables to, let's say, it could be some other different engine, because you can also use the logical replication, logical decoding plugin, and even Debezium or some other connector can request for the decoded information and probably publish that to any subscriber, right? It could be even Oracle, it could be SQL Server, it could be something else, right? It can just let even Kafka write it to multiple subscribers. So, considering Postgres growth extensively, right, over the past few years, as Postgres has become the de facto, the capability of replicating selected tables also has grown. So now when you use logical replication on the publisher, right, which is on the primary server, I mean to say, when you do that, there is some extensive load on the primary or the writer instance, because the decoding has to happen on the writer side. So now that can be shifted to the standby server, right? So there are several other improvements too, and a new implementation or new addition of SQL JSON constructors and identity functions, monitoring enhancements, as well as some of the improvements, especially related to pghpa-conf and ident.conf from security perspective, where you can also provide regular expressions, right? And majorly, we can also talk about the libpq enhancement, right? Now, through this enhancement, you would be able to go ahead and add multiple hosts and let the driver behave as a proxy, similar to consider it as a HA proxy, right? Which is able to kind of redirect some of the transactions or sessions to are distributed between different instances. So that is something that you would be able to apply with the libpq enhancement in Postgres 16. Postgres 17, that's going to be announced soon, which we haven't included here yet because it's not yet, it's still in beta. It's going to come up with amazing more improvements. So you have to try getting to the latest version as much as possible. So libpq will explain that at the end, during the Q&A. So let's now talk about the upgrade techniques majorly, right? So Postgres upgrade. Now Postgres is deployed on-prem, as well as Postgres is also deployed on cloud, right? So most of the Postgres installations are also happening on cloud. Like you may have an AWS EC2 instance or a GCP Azure cloud virtual machines or physical machines, right? Dedicated instances. Wherever you are, yeah, you would be able to install and set up and use it. At the same time, there are also DBaaS platforms where you, like RDS or Aurora on AWS, or Cloud SQL for Postgres, or Azure database for Postgres. All of these DBaaS platforms also have got Postgres deployed. Now, I mean, also have Postgres, which users are using today, right? All of these versions, all of these deployments need to have some upgrade strategy. So today we'll be talking more on the on-prem, but a lot of these are applicable for cloud also, right? So let's talk about some of the upgrade techniques that we're going to talk about, right, today. So we'll be discussing 5 upgrade techniques today: PG dump and PG restore, PG dump all, PG upgrade without hard links and with hard links, logical replication, right? So regarding cloud, if you're talking about AWS, you have in-place upgrade capabilities, you have blue-green deployment, and logical replication, which we are also going to talk about. DMS, which uses logical replication under the hood, right? And even with GCP, you have in-place upgrade and DMS and logical replication. Under the hood, all these cloud platforms use logical replication technique mostly, especially to make this upgrade technique as seamless as possible, eliminating the downtime or reducing the downtime to the least. So let's actually start with PG dump all. Maybe Mani, you could go ahead and start that.
So in PG dump all, right? So this is one of the oldest upgrade techniques that's being done in Postgres, right? This is basically taking a SQL dump from the old cluster, and then with the help of the new binary, which means like if we want to move from Postgres 12 to Postgres 16, then we would use the Postgres 16 binaries to take the PG dump all. This includes all the databases in your cluster, including the users, global objects like table spaces, and any n number of databases that you are going to have, right? So you would be taking the dump with pg dump all, and we'd be using PSQL client binary to restore it in the target version. Let's say if we are going to move towards Postgres 16, then we would be using the PSQL command, and we'll pass the SQL dump file to it, right? And what are the advantages? So primary advantages is we do not want to move the users and roles separately, and it moves the entire cluster, including all the databases. But you see this, right? If you see this, the cons are majorly right. It is not suitable for a very large database set. So databases that have terabytes of data, in those environments, this PG dump all is not much suitable upgrade method, because it requires a downtime. When we take a dump, we shouldn't allow any users to connect. Similarly, until the restore is completely done, we wouldn't be able to use our application, right? So it has a very longer downtime, and it doesn't have also any kind of parallelism to take the dump and do the restore, right? So next would be how we do the PG dump all, right? So in terms of tests, so we would do an initdb to initiate the new Postgres cluster, right? And we would use pg dump all command with user accounts and with the username, which would be the super username, and we would use the appropriate host name, and then redirect the output to a backup file. Since dump all doesn't have any kind of custom modes, it would be a normal SQL backup file, right?
So maybe we can actually directly show the demo as well to make it a little more simple. Okay.
Okay. So let me bring up.
So what we'll be doing is we have two instances, right, running on Postgres 12 and Postgres 16. So we will be doing a quick demo of each of these releases and each of these upgrade techniques as much as possible, right? And so now we are going to show the PG dump all technique real quick. Yeah, perfect.
Yep. So let's quickly go over all the demo of it. So I'll quickly initiate a Postgres 12 instance in the host, right? So I'm using Postgres 12 binaries to initiate this instance. So we will create a test bed, basically, with few tables. So once the initialization is done, I'm starting the Postgres, and we'll create few tables with few rows just to make the demo quicker with the help of pgbench, right? So pgbench is another utility that can be used to create a data set quickly, right? So let me just go with this one. Okay. So now what we'll do is we will take a dump with the help of pg dump all command. So the options that I'm using is host name, username, and the port, and redirecting it to a file, right? So this would log into each and every database and create a dump file, right? So once the dump is completed, we would stop the old Postgres instance that's running, and then initiate a new Postgres with Postgres 16 binaries, right? And then start this Postgres, right? So before starting, right, since we are migrating from Postgres 12 to Postgres 16, so we need to make sure that so as we already mentioned, we need to make sure we need to read the release notes, and then and then make appropriate adjustments in the upgrade plan. All right. So since we are moving from 12 to 15, the default encryption of the passwords of the user accounts are changed from from MD5 to Scram SHA 256. So we'll also see how to fix that when we are doing the actual upgrade. So what I'm doing is I'm setting the encryption to again MD5 in the upgraded Postgres instance. Right. So now we will start the Postgres 60, right? So once the Postgres is started, right? So we will do the restore of the dump file that we took.
So ultimately, what we really did is we have a Postgres 12 instance. We use a simple PG dump-all utility to completely take the backup of the entire cluster and simply restore that to a Postgres instance with version 16. So from 12 to 16. However, the important point to note is that it is always recommended to use the latest version binary, right? So the PG dump all that you're going to use should be of the latest
Postgres
version,
16
right?
version.
So if you are migrating from Postgres or upgrading from Postgres 12 to 16, the PG dump all has to be of Postgres 16 version, right? So that's how you need to take care of it. Yeah.
So once the upgrade is done, so as we mentioned, so we need to make sure that the password encryption technique is again changed to Scram SHA 256, right? So I'm changing the encryption technique again, and then since it doesn't require any reload, we will do reload here, and then we again need to reset the password of any user accounts that we have, right? So if since we are moving from 12 to 16, so this would be the upgrade method for doing the upgrade from Postgres 12 to Postgres 16 with the help of PG dumper, right? And we are doing reindex because it is actually a recommended thing. Yeah. So next thing is to
Yeah, the reindex is something that you have to remember because when we discussed about the Postgres 13 features, we discussed about the bit reindex deduplication. However, if you would like to take the benefit out of the reindex, I mean the deduplication, you must reindex. If you don't reindex, then you will not be able to let that bit index deduplication be applied. However, this reindex is something which you may not need to worry about, especially with the PG dump all technique or the PG dump and restore technique, but especially with the PG upgrade utility, right? Especially when you have used the hard links feature, that is when you must be looking at the reindex. So in this case, it's still fine. However, the general process is that for you need to see how you can reindex.
Yep. So the next step that we will be doing is we move towards Postgres upgrade with the help of hard links, considering the time constraints that we have.
So you want to show the slide about the hard links?
Yeah. So, yeah. So another method is dump and restore, which is more similar to what we have seen now. But in dump and restore, we wouldn't be dumping the global objects. And again, it still requires a significant amount of downtime and a very not good process for a large Postgres database instances, right? So, moving towards the PG upgrade with and without hard links, right? So we'll start with hard links, and then we'll move towards, or we'll discuss about what's the difference between with and without hard links soon. So so to see a demo about with and without hard links, we'll again initiate a Postgres instance here with Postgres 12, and then we will start this Postgres instance, right? And we'll create a test bed of a small data set, right? So once this is done, right? So we will create a target Postgres data directory, which would be the Postgres 16, right? Once this is done, we would be using PG upgrade binary. This utility comes inbuilt when Postgres is being released. Every major version gets released. It comes with the PG upgrade binary. So this actually helps us to upgrade from a lower environment to a higher environment, right? So what is this command? So in this, we pass the binary of the older Postgres, the current Postgres version that we are in, and the binary of the target version that we are about to, and the data directory of both the current data directory as well as the target data directory, right? And before doing the actual upgrade, it is always good to do the check whether the upgrade is going to get successfully completed or not. This check basically covers all your current installed extensions, whether they are compatible with with the target versions, and if it's not compatible, it's going to report you an error, similar to the report that's being shown here. All right. Okay. So the next step would be the upgrade process, the actual upgrade process. Right. So the only difference between the old other command and the current command that I'm going to execute is the elimination of this -c. Right. C refers to the check basically. So now, okay. So before that, we need to shut down the PostgreSQL as well, right? So without shutting down, you wouldn't be able to proceed with the upgrade. So once that is shut down, we will do the upgrade process. So this actually copies the existing data directory files to the new data directory that we have shown there, that we have given in the -D. Once it lets us know that the upgrade is completed, then we would go ahead and start the upgraded Postgres instance and then do the pre-checks.
Yeah. So another important thing to know or remember is that whenever you're using PG upgrade with hard links or without hard links option, right? Currently, what we are demonstrating is without the hard links, the general PG upgrade technique. So whenever you're doing that, you may be facing inconsistencies, especially when you have extensions, and you'll be able to see that when you do a compatibility using the -c option, right? That is when it is required to have the latest version of the extension supporting the major version also installed. Sometimes there may be scenarios where you have to drop some of the dependencies of the extension, like you have a function which is basically pointing to one of the oldest PostGIS releases method, right? You may have to drop that function, recreate it after installing the new PostGIS extension. So there are certain things that you have to handle manually, especially with this approach.
So once the upgrade is completed, we do the post upgrade steps. That would be doing a reindex, and it is always advisable to run a vacuum analyze on all the tables whenever you are upgrading from the older version of Postgres to a newer version of Postgres. So this is all about Postgres without hard links, right? So the difference between with hard links and without hard links is that, right? In case of without hard links, the entire Postgres data directory is copied from your older version to the newer version, right? On the with hard links approach, it just creates a soft link between your existing Postgres data directory files and the new data directory that we would be initializing. All right. So, and then as soon as we start the Postgres instance, right, the old data directory becomes unusable. Basically, we can't use it.
Yeah. To add to that, right? So what it means is, let's say you have the older data directory of Postgres 12, and you have new data directory of Postgres 16, right? So now with the hard links technique, what really is happening is all the files and directories, and ultimately your database schema, or not the schema, but the database as well as tables, especially the relations or anything else, under the hood are files and directories within the data directory, right? Or maybe table spaces, etc. So now you will have the latest version data directory containing the same files and directories pointing to the inodes of the older data directory. So that's basically the simplest approach the hard links approach gives us, right? So with this approach, you really don't see data moving. So it's ultimately for terabytes even, you may see it happening within 10 to 20 seconds. Even terabytes of databases can be upgraded pretty quick with the hard links method, right?
Okay. So the next approach that we have, all right, is the uh, upgrade with the help of logical replication, right? So this would be the most interesting upgrade methods that we generally do,
Yeah,
right?
so maybe I can present that
Yeah.
real quick on one of the instances, right? So the logical replication approach is one of the interesting approaches because it can also support upgrade between multiple major versions, and at the same time it can actually eliminate a lot of downtime, right? So maybe I can connect to one of the instances and show you. So yeah, so to keep it simple, logical replication requires the data to be copied from the current instance to the newer version Postgres instance, but there will also be a replication setup between the current instance, which is, let's say, Postgres 12 to Postgres 16. Once the replication is in sync, you can find a certain point in time at which you can switch the application, right? So that is a strategy that you can really take. And it's also simple to roll back, right? So it's minimal downtime and you have a lot of control. However, you have to take care of certain scenarios, like you should be avoiding DDLs and carefully handling, replication of sequences, etc. So let's actually see a quick demo of the logical replication approach. It's very, very simple, just a 2-3 step approach, right? So is that in the same instance? Okay. So we will actually connect to a different instance. So I have both Postgres 12 as well as 16 instances or clusters running, right? And we also have certain important parameters that are mandatory to be set, also part of these configurations, like wall level has to be logical, right? So there are some other parameters that can be tuned to optimize the replication, but for the purpose of presentation, we're just demonstrating very few settings, right? So what I would simply do is, now I have, as an example, a lot of tables, especially, let me connect to one of the instance here, okay, and show you that this database size, the database hexa cluster is of size 462 megabytes with, let's say, PG bench tables with partitions included, right? So you also have partitions in this instance. So now we will be setting up replication from Postgres 12 to Postgres 16 using logical replication. All we need to do for that is create a publication on the uh, uh, Postgres 12 instance. So to create a publication, all you need to do is pass this create publication, provide a publication name and say for all tables, right? You can also specify a lot of interesting customizations like only selected tables, etc., which we are not concentrating in this presentation. Once done, you need to create the same schema as the hexacluster database in Postgres 12, right, in the Postgres 16 instance. But notice one thing here. I'm taking the PG dump, basically the schema only dump from the Postgres 12 instance using Postgres 16 binary. So it's always important to use the latest version binaries whenever you're performing upgrades, right? And then I'm dumping the schema to the Postgres 16 instance running on port 5834. So once done, all I would do is execute a simple command, right? And that simple command is create subscription. So we are creating a subscription on the Postgres 16. So publication is created on the Postgres 12 instance, and the subscription is created on the Postgres 16 instance. And as soon as I create the subscription, the existing data is replicated, and it's copied, and the replication also starts. You can also break logical replication into multiple parts. What it means is, let's say you have terabytes of database. You may want to migrate the already existing data faster and then enable replication. You have multiple strategies to do that. You can set up replication and then look at the LSN at which you want to really cut that replication, create a publication. You can do all of that. We can separately connect regarding that, or maybe plan that in a different webinar, considering the time constraints. But all of these are possible, right? So now what I'm doing is, using PG Bench, I'm just running some, certain transactions for a set of, for a period of 10 seconds on the publisher, right? So my goal is to see whether all of this data on Postgres 12 is replicated to Postgres 16 or not, right? So now what I would do is, I will connect to the Postgres 12 instance, right? And then, which is basically the publisher, right? So Postgres 12 instance, and then look at the replication status. So to simply look at the logical replication status, I would be able to query the PG replication slots view, right? So when you query this, PG replication slots, you should be able to see the difference, especially the replication lag as 0 bytes. So I'm looking at the current LSN as well as the confirmed flush LSN, and then understanding what is the difference. So it's very simple. Now the replication is set up between Postgres 12 and 16. All you need to do is just switch your application, right? So if you have terabytes of database, you can still use the logical replication approach, but for the one-time copy, you can use pgdump, pgrestore, or even streaming replication and set up a very smart technique, right? So it might get slightly complicated if you have a very complicated setup, but it works. I think, seen, including Money, myself, and our team at Exacluster, have seen really complex upgrades. So write to us just in case if you have any complex upgrades and you want to design the strategy with us, right? So that is not a challenge. Now, we will continue the presentation. And so these are some of the commands. The slides will be shared and the recording will be shared. So not a problem. You can always go through the commands as well. But we'll also be publishing some blog articles on the same. So in a gist, we have seen the PG dump all technique where downtime is involved and where disk space is also required, right? Complexity is very low, requires re-restoring the backup and complete cluster backup and migrate. PG dump and restore are also similar, right, to PG dump all, with some capabilities to avoid the disk space usage, but that is still similar to PG dump all. PG upgrade without hard links, right, is one of the simplest technique, easier rollback strategy, but requires some disk space. And the hard links approach, if you are especially doing in-place upgrade, and if the new instance need not be on a different disk altogether, then the hard links approach is absolutely fantastic. But you still need to re-index if you are upgrading from a version before Postgres 13, because you want to take the advantage of deduplication of B-tree indexes. And the last option, logical replication, there is definitely some complexity, but you can reduce the downtime. And also, you would be able to have several techniques involved to optimize the migration time, as well as the interesting fact is that the performance can be considered to be improved with logical replication. Why? Because you will be eliminating a lot of load and you are actually rebuilding the entire database using the logical replication technique. So all the fragmentation is gone, right? So PG upgrade with hard links can still continue keeping that fragmentation, but at least helps you move to the major version faster, right? So these are some of the things that you need to be remembering, especially while upgrading. Now, Finally, a few points to remember in a minute. Always test your upgrade strategy. So these are not just the only upgrade strategies. There are some more. You need to customize it based on the requirement, or speak to experts like us so that we can help you customize it. And it's important to perform an end-to-end application testing because there may be some compatibility issues. I remember a scenario where OID support was removed and some of the applications were broken, right? So it's important to but that's extremely limited. You will not really see most of such compatibility issues in Postgres world, right? You will never see that usually. It's very limited. So you also have to update your monitoring scripts and custom jobs, because that's now with the new binaries, right? If you are hard coding, or also if there are catalog changes, for example, in pgstat statements and pgstat activity, you probably see new columns or attributes being added to the catalog tables or views, and some of the old attributes being renamed. So you need to look at that. And it's important to plan an upgrade strategy with rollback in the event of failures. And make sure to look at the collation and locale and time zone settings, especially when you're migrating from one OS to another. This can really break the system, right? It shows the upgrade as successful, but it can break the application. And the configuration parameters changes have to be considered. You have to go through the release notes before even performing an upgrade. And do not be an early tester in production database. Wait for two minor releases. Just because Postgres 17 is being announced, do not directly upgrade in production unless you have an option to handle that, right? But wait for two minor releases so that some of the bugs, etc., can be fixed. But test it in non-production environments. Absolutely, that's how we improve Postgres. So sorry, we haven't given much time for questions, but we will still take some questions. Let's look at the chat here. Maybe we'll stop presenting for a moment, right? So I think, yeah. So looking at the questions, right? Database security, we have covered that. So there are some versions which actually have a lot of security specific enhancements and releases, right? Maybe we can publish an article on that, right? On all the security enhancements, version specific security features, like row level security, column level security, as well as some of the roles and the public schema specific improvements, right? And okay, so in addition to that, is there any exception like the prior version features doesn't belong to? Yeah, you would really not see such exceptions. So always, if you have Postgres 12 features, when you are moving to Postgres 13 as an example, it's basically built on top of the Postgres 12 features. There may be very tiny scenarios where some features can be eliminated, but that's extremely low. It doesn't happen that way.
If that is the case, then there is already going to be an alternate feature that covers the existing one. Mostly it would be like that only.
Yeah, it never happens like the features get eliminated unless there is some bug with which the feature is actually completely rolled back for all the releases, right? So at the same time, libpq is consider it as a client library, right? So if you look at the driver like psychopg2 or even Perl dbx, or most of these even Go pgx, right? All of these are built on top of libpq under the hood. It's a C API technically to begin with, right? It's a library. JDBC again has its own implementation, so that's a different story. So logical replication upgrade, yeah, we have shown the demo. Perfect. Gautam has actually answered already from Hexacluster about libpq. And so other than that, okay. So let's see if we have any. Has there been any upgrade in functionalities in PG dump and PG base backup?
Just one.
Yeah,
the table space on a different mount space, right?
Table space on a different mount space.
Mount.
Yeah. So I think so when you say different mount space, yeah, basically all of these upgrade techniques also supports the concept of table spaces, right? So and that is not a challenge. You always have the option to like say what was the table space location earlier and what's the table space location now, right? So you have the option to state that, especially when you're starting Postgres instance. And Also, do we need to stop database before running PG upgrade command? I think Mani has already demonstrated that, right? So rollback with hard links, as Mani explained, yes, it is possible. And also, reindex is different than that two script analysis. So yeah, with PG upgrade, you have delete cluster, analyze cluster, etc. Right? But
it's not advisable to immediately do that because just in case if you need to do a rollback, right? So it is always better to do the cleanup after few days or few weeks, basically.
yeah, not delete the cluster right away, but yeah, you can do all of that as well. And there is another thing that you also need to be aware of, right? Reindex has to be performed when you have to perform, right? So you need not really do a reindex all the time. It's great if you do that, but especially with PG upgrade with hard links approach, yes, correct, agreed. But what is the improvement that you're going to get? If it's about B tree index deduplication, Postgres 12 to 13 or 11 to 13, it's valid, right? In other scenarios, you have to see whether there are any index specific features that force you to reindex, right?
And all these details are usually mentioned
Excuse
in
me.
the release notes as well.
Yeah, you can look at the release notes. So AWS Postgres upgrade process probably will have a separate article or a webinar, maybe, right? And logical replication. Let's do one thing. Yeah, we can definitely plan an immediate session completely about logical replication because many people are talking about that, right? Can we do streaming first and logical replication? This is one thing, right, Ganesh? That's actually one of the interesting approaches. Yes. So there is a way to do that, right? You have to ensure that you're not missing transactions. So you have to be careful, but it is possible. We have done that. And yeah, we are planning to upgrade one of our databases from V14 to 16. Database size is around 3 terabytes. Do we need to reindex? So when you say 14 to 16 and database is 3 terabytes, right? See, reindex can always be beneficial, right? Especially depending on the upgrade technique that you're using, right? So if you're using logical replication, you really do not need to worry about that because you already have the schema and data like completely refreshed and created in the new instance. So it's already, but if you're using PG upgrade with hard links and you have not really performed some of the maintenance operations in the past, yes, it is definitely a good one to do, right? Because it's going to be eliminating a lot of index load. Remember, indexes, I've also mentioned this earlier, indexes are majorly the culprits in terms of performance. So what it means is if you have index really bloated due to whatever reason, right? Because of frequent updates, deletes, etc. happening, right? And you haven't tuned some of the important settings, then it's good to know that you have to reindex. So yeah, remember that that reindex can be helpful depending on the upgrade technique. So it could take a lot of time, but you have to parallelize that and you have to take care of it
You can use concurrently option as well, right? So
you can also use concurrently option to make it online so that you're but ultimately it's going to add some amount of computing effort, which could be hampering some of the live traffic. So you have to be very careful about that. I think these are good questions. You should be able to reply back to learnings@hexacluster.ai if in case you have any questions or further clarifications required. Connect with us at connect@hexacluster.ai, right? So with that, you would be able to at least get some support, especially when you're planning complex upgrades. So speak to experts like us always. Uh, we also wanted to mention that we are about to announce our AI chatbot for Oracle PG, right? So we will be sending that announcement soon, and you should be able to use the AI chatbot just in case you're willing to migrate from Oracle to Postgres. So we'll be sending that, and we'll be announcing that today. So please watch out our announcement, and please feel free to use that tool.